Okay, the final step to our lab is to look at a short circuit in parallel and try to troubleshoot that and find that. So we've modified our setup according to the instructions. We did add a 120 ohm resistor, and what I did, or what I like to do, is I put that on the end of the bus line, and I've hooked my negative supply line into that resistor, so it is in series, and basically that's simulating the internal resistance of the power supply. For our purpose, it's a protection resistor. It does change the circuit characteristic a little bit when we're looking at things overall, but it's a protection to keep things from burning up here when we short this out. We also modified our power supply to be 7 volts. So we're bringing 7 volts into the circuit. Again, the rest of the circuit setup is very similar. Now I've taken this yellow alligator over here and I've hooked it to resistor 1. This is what's going to be creating my short. Before we do that, I want you to look really carefully there at the light. You'll see it's a very dim glow. And I could turn the voltage up a little bit and get a little more of a glow to that, but I just need an indicator that current is flowing there in the circuit. Now, you know from previous labs that when you create a short in parallel, everything goes out. So here we go. We're going to short this guy off. And notice my dim glow has gone away. Okay. If I measured volts with a voltmeter here, what do you think I'm going to see? Let's go ahead and check. We're going to check voltage. So I'm going to take this guy, turn him back to volts, and we'll put our negative probe there and our positive probe here. So looking at resistor 2, looking at my volts, I have 0 volts. I'm going to see something similar for all of these. And why do you think that is? Why do you think that we have 0 volts with our short in place here? So it doesn't matter where I go on here, I'm going to read 0 volts. The next check you're going to end up doing is the resistant check. And so we're going to turn our power supply off, and I'm going to remove my power probes, and then we're going to check for total resistance here. So I'll pull this out. We're not going to factor in our internal resistor up there, and we're going to look using an ohm meter. What do we see with the resistance check here in terms of total circuit resistance? So on my positive side, I'll hook that in, and on my negative side, I'll hook that one in. Okay, and when I look over here, I have 4-ish ohms, 4 or 5 ohms. Now remember, initially in our circuit setup, we were at 15.4 ohms, and you know, here with our short in place, we are seeing a pretty low resistance. Well, now I guess it's down to 2 ohms as it settles out. We were really low resistance. The wire does have some resistance in it. This could be as low as 0 ohms, but these alligators actually do have some resistance. Remember, in parallel, total resistance is less than the smallest resistor in there. So we're accounting for some of the resistance in wires here to get such a low reading. Actually, it's still settling out, still dropping over there. I'm down to 1.8, 1.7 ohms as things kind of settle out. So my resistance is extremely low with that short. Unfortunately, isolating a short in a parallel circuit is an extremely difficult task. If we go through and remove each of these components, well, let's see what happens to our resistors. So I'm going to remove the light bulb, and as I pull the light bulb out, I'm still at that low 1.5. I'm going to remove resistor 2 and pull it out, and well, it's jumping around and settling out again, but I'm still at a pretty low value. My short is because there was no change. My short is kind of an obvious piece there. Now, if I went back through and I removed the shorted resistor, what I would see is my resistance would jump up. So isolating a short using an ohm meter is a difficult task, but it can be done in troubleshooting parallel circuits. Use this information, answer your questions, complete your lab report, and ask if you have any questions.